Good morning and welcome to results-oriented preparation. Remember our motto, early preparation equals excellent results. Today we're continuing with our probability and we're looking at mutually exclusive events. Mutually exclusive events. Mutually exclusive. Right, mutually exclusive events. Okay, now when events are mutually exclusive, all right, it means that the events cannot happen at the same time. So events cannot happen at the same time. All right, so that is the guiding principle when you're looking at mutually exclusive events. So each of them are mutual and they exclude each other. All right, so meaning that one event cannot happen at the same time that the other event is happening. All right, let us look at an example. All right, e.g., for example, if you roll a die. All right, roll a die. All right, you know that the plural for that is dice, singular is die. Now if you are rolling a die and it is impossible for you to have two numbers on the die at the same time. Okay, now if you roll a die, it is impossible. It is impossible for it to land on a 1 and a 6 at the same time. So in other words, what we're saying is that 1 and 6 are mutually exclusive because once you roll a die, it is impossible for it to land on 1 and 6 at the same time. All right, so it can only land on one side at one given time. The die can only land at one side. So therefore we can easily say that 1 and 6 on a die, when you roll it, 1 and 6 are mutually exclusive events. All right, 1 and 6 are mutually exclusive. So therefore what we can say is, that is full stop. So therefore the probability of a 1 and the probability of a 6 are mutually exclusive. All right, meaning that we cannot have those events happening at the same time. Okay, but now let us try and represent this mathematically. Now we were just writing it from a theoretical point of view so that we can associate the words that we are using to the mathematical operation that we are going to perform. Okay, so basically we're saying we've got two events. You are rolling a die and want to see the chances of a 1. Roll a die, and then what are the chances? What are the chances of a 1 or a 6? All right, what are the chances of a 1 or a 6? Now in probability, the chances of a 1 or a 6, so we write that as the probability of P of 1 or 6. All right, the 1 or 6 you have to be in bracket there, is equal to the probability of 1 plus the probability of a 6. So the probability of a 1 or a 6 is equal to the probability of 1 plus the probability of 6. Okay, now we know that we've got 6 different options. 6 different options in a die: 1, 2, 3, 4, 5, and 6. So the probability of having a 1 here is 1 over 6. And the probability of having a 6 again is 1 over 6. So 1 over 6 plus another 1/6, that will give you 2 over 6, which gives you 1/3. So the probability of 1 or 6, right, is 1/3. Okay, so therefore we can rewrite it as probability of 1 or 6 is equals to 1/3 or 33.3%, because you can express the probability there as a percentage. All right, 1/3 is 33.3%. Now, what we want to do then is we want to express that using, we can express this using a Venn diagram. All right, remember in our last lesson we were looking at Venn diagrams. Now we can express that as a Venn diagram having the S. We say that the S stands for the sample space. Now the sample space in our case is all possible outcomes, all possible outcomes for rolling a die. All right, that is our sample space. All right, so this is then going to be our Venn diagram. All right, now remember that the rectangle there represents the sample space, meaning that all the possible outcomes are within this particular sample space. And then we'll have 2 sets here. We'll have 2 sets there. So this one is rolling a 1, and this one is rolling a 6. These are the 2 events that we want, but we know that all the possible outcomes are not only 2. We've got 6 possible outcomes, which will include rolling a 5, rolling a 2, rolling a 3, and rolling a 4. All right. So now in a Venn diagram, all the possible outcomes are within that sample space, all right, which is your S. And then the 2 mutually exclusive. I want you to see, because from here you can really visualize that these 2 are mutually exclusive. Now remember, if they are mutually exclusive, it means that they do not intersect. One is independent of the other, one is separate from the other. So there is no intersection between rolling an A and rolling a 6 there. So as a result, if we're saying P, A, and B, right? A and B is equals to 0, all right? Because there is no intersection. There is no intersection. All right, the 2 sets do not intersect. The 2 events are mutually exclusive. All right, the 2 events are mutually exclusive. Now, we can still go further. We can still go further with this. If you're going further with that, what you're basically saying is you can also look at the number of elements in each set. The number of elements in a set. So the number of elements in A or B, for mutually exclusive events is equals to the number of elements in A plus the number of elements in B. All right? The number of elements in A plus the number of elements in B will give you the total number of elements in A or B. However, we can still express this differently there. We can say again that A intersection B is equals to an empty set. Now, if you see a 0 like this, cancelled, a diagonal, it means that this is what is known as an empty set. Alright, it is an empty set or a null set. Okay, and also A union B is equals to 0. Alright, so because A and B are mutually exclusive, so A intersection B is an empty set and A union B is 0. And also the number of elements in A or B which are mutually exclusive is going to be equal to number of elements in A plus the number of elements in B there. Okay, now let us quickly look at what is known as complementary events. Now, this was mutually exclusive, just an explanation. Before we actually do one or two calculations, let us quickly look at what are known as complementary events. Complementary events is our subheading. Complementary events. Okay. Complementary events. Okay. Now, be careful of the complement that you see. It's got an E instead of an I. The one with an I complement is like to complement something or someone. Like you say, or you look great. That is a complement with an I. But our complement has got E. This complement meaning, to complement meaning something that completes. So it's from the word complete, right? It's something that completes an event, or it adds what's missing to make up the whole. That is to complement, to add what is missing to make something whole. All right? So therefore, a complementary is an adjective of complement, meaning that it's an event that completes or adds to another event to make up the whole sample space. All right? Okay? So events that are complementary. All right? Complementary events are events that are mutually exclusive. They are mutually exclusive and complete, or adds to other events. To make up the whole sample space. Okay, they make up the whole sample space, they complete or add to one another. You've got two mutual, or how many mutual events? The mutually exclusive events, when they add each other, they complete each other to make the whole sample space. All right? So events when they're mutually exclusive and then add or complete each other to make up the whole sample space are known as complementary events. Okay, now let's look at the example again that we used. We were using a die. Now, the sample space for a die is going to be, 1, 2, 3, 4, 5, and 6. right? That is the sample space for a die. All right. Now, what is the probability here of rolling a 4? The probability of rolling a 4, the probability of rolling a 4 there is equals to 1 over 6, right? That's the probability of rolling a 4, all right? But what is the probability? What is the probability of not rolling a 4? You see, when you see that this sort of apostrophe there, small mark on top there, that means probability of not rolling a 4. All right. So this will be 5 over 6, right? Now 1 over 6 is the chance that it will be a 4. Now the other chances that are not 4 are 5 over 6. So the probability of not rolling a 4 is 5 over 6. Now you will see that the two complement each other to make the whole. The whole is 1, therefore 1 over 6 plus 5 over 6 will give you 6 over 6, which is 1. So these two here, they are complementary events. All right, they complement each other. All right, now let us try and put that in a form of a Venn diagram. Let us put a Venn diagram there and see how we can express that. All right, there is our Venn diagram, and then we've got S, which is our sample space, is all possible outcomes for rolling a die. The possible outcomes for rolling a die, and then we've got roll a 4. Roll a 4, right in the center there. All right. This is roll a 4. This is a 5, a 6, a 1, a 2, and a 3. All right. As you can see, the probability of rolling a 4 is 1 over 1, 2, 3, 4, 5, 6, right? So that is 1 over 6. But the probability of not rolling a 4 is 1, 2, 3, 4, 5 over 6. All right. So in that way, we have the two rolling and not rolling a 4 being complementary because they make the whole sample space there. They make the whole sample space. Now, if you're going to express that in general terms, you say probability of rolling a m plus the probability of not rolling an a is equals to 1. All right, because these two, they complement each other. So therefore the probability of not rolling a is equals to 1 minus the probability of rolling a. Or alternatively, the probability of rolling a is 1 minus the probability of not rolling a, because both this one, probability of a, and the probability of not rolling a are complementary events. Okay, are complementary events. Now let us look at a question that we can do to apply what we have learned there. Now the question is as follows. We're given a sample space. If S, which is our sample space, is 1, 2, 3, 4, 5, 6, and 7. All right, that is our sample space. And then we're given that the elements in set A is 1, 3, the odd numbers, 5, and 7. All right? And set B is equals to 2, 4, and 6. All right? So those are our sets. Okay? We've got the sample space, which is 1, 2, 3, 4, 5, 6, 7. And then sample A is the odd numbers 1, 3, 5, 7. And then sample B, event B is 2, 4, and 6. Okay? So now the question says, what is the probability of choosing a number that is not in set A? What is the probability of choosing a number that is not in set A? That is not in set A. Remember what we just said, all right? Probability of number that is not in set A is equals to 1 minus the probability of set A. All right? 1 minus the probability of set A. So therefore, substitute 1 minus what is set A? 1, 2, 3, 4. There are 4 numbers there, and the total is 7. So that will be 4 over 7. 1 minus 4 over 7 is the same as 7 over 7, or we can write this as 7 over 7 minus 4 over 7. All right, which will easily give us a 3 over 7 there. So the probability of not choosing a number that is in A is 1 minus the probability of a number that is in A, which is 1 minus 4 over 7, or 7 over 7 minus 4 over 7, which will give us an easy 3 over 7 there. All right, now let us quickly look at a different question here. Let us look at another question. All right. Okay. Now, in the next question, we're given that a DVD shop has 180 comedies. Has 180 comedies. Has 250 drama films. 250 drama, and then he has got 230 science fiction, and then he has got also 120 thrillers. Okay, 180 comedies, 250 drama, 230 science fiction, and 120 thrillers. Now, if you select a DVD at random, okay, select a DVD at random. All right. What is the probability that the movie is comedy or a thriller? What is the probability that the movie is a comedy, or thriller? All right. What is the probability of that happening? That the movie is that. So you remember what we need to do first. Look at the events, right? You can see that all these events are mutually exclusive. There is no overlap there. There is no comedy that is a thriller, or there is no comedy that is drama. All right? There is no comedy that is science fiction. So each of those are mutually exclusive. So meaning that there is no intersections or overlap between or amongst these 4 genres of movies there. So what we're going to do then is we need to find the sample space. We need to find the sample space, which is S is going to be 180. Is going to be 180 plus 250 plus 230 plus 120. All right. Now a quickly addition there will give you, this is 300, and then that is 480. So that will give you 780. All right. This will give you 780. All right. There's 780 total movies there. Now we want to see what is the probability. The question says, what is the probability that the movie is going to be a comedy or a thriller if you were to choose at random? So what it means is we're going to look at P, comedy or thriller. All right. But remember that the two are mutually exclusive. So therefore, we're going to have P, comedy plus P, thriller. All right? P, comedy plus P, thriller, which is going to give us how much in comedy is 180, which is 180 over the total, which is 780 plus the thriller has got how much? 120. So we've got 120 for the thriller divided by 780 again. So this will give us 300 over 780, 300 over 780. But you can simplify that further to let's see. You've got 13, 3, okay, you've got 5 over 13. All right, you have 5 over 13 if you simplify that further. Okay, now this will give you the probability of either having a comedy or a thriller. Okay, so we can leave it here for now, but make sure that you ask as many questions as you can. I hope you really enjoyed this presentation. I will see you in the next video.